Hello everyone, Greg Latch here from Emerson, Australia. Thanks for joining us. This is also taped for those that would like to also potentially send this link on. And I'm proud to say this is the first of several live webinars for this particular series. Looking at the dates, on the 22nd of November, we have Andy Kennard presenting, talking about their DCS controllers, rethinking the role of that particular space, the DCS systems. And I've actually got another session on myself on the 29th of November talking about the combustion process. So without further ado, we'll definitely go through the slide piece. It's an open forum for questions, Q&A. Please, if you can, type through your questions, and then what I'll do, I'll go back through and review them, and we'll have a bit of an open session towards the end and hopefully cover those topics. Got myself a little bit of a hit list here. Yep, I think we've pretty well covered it. Just and very much towards the end as well. There is a little bit of a survey through our continuous improvement process. What we would really love is some feedback from yourselves, on the content, the topic obviously, and any other areas you think we could improve in to help these be more applicable to yourselves and your applications in particular. So without further ado, we'll move on. So today's session is how to extend your safety network for toxic hydrogen gas. We'll start with a safety moment, then we'll talk about H2S for those that are maybe potentially unfamiliar, some of the installation challenges and considerations for H2S, and also usually just general gas detection. We'll look at the 928 platform and the 628 H2S sensor. We'll talk about the safety suite that we have in our portfolio as well, very briefly. And probably one of the other tie-ins you may or may not be aware of is how that actually ties in to Emerson's digital ecosystem, and in real terms extending your safety network, which I'm actually really excited about over and above just the 928 release in its own right. Emerson has in its remit globally, we actually have 12 life-saving behaviours. One of the key points, and myself being an ex-hands-on engineer and obviously now in a BDM role, I've worked with some absolutely brilliant people over the years. Ring spanners were definitely a must in some sites, which I used to applaud, and obviously for that situation, it's a tool of choice if you can. Obviously for the right tools for the right jobs is very much key. I think it's fairly self-explanatory, but in the same context, clean workspace, being prepared for the role and the job is definitely front of mind. So it's one of our 10 life-saving behaviours that we have in the Emerson mantra, and using the right and correct proper tool for the right role and job. Without further ado, we'll throw into the key points for today really is everyone's health and welfare is exactly that. It is paramount. I've been fortunate enough, I have not had any situations or issues that couldn't be managed, if that makes sense. So from running workshops right through to having key staff for construction work and the likes. I've only had some small minor incidents. I haven't had a major incident under my role and watch, so I'm being very lucky with that. But this particular space in the safety areas, it should not be belittled in any way, shape or form. And I suppose my rollout, or a little bit of a comment, is let's get everybody home safely. H2S covers a lot of different areas. It's not 100% always well identified and known. It can be, dare I say, a little bit of an insidious sort of style of gas. The unfortunate part, it does and has had major impact on families. And again, to use that comment, I have not ever had to make a horrible knock on somebody's door to say one of your loved ones have passed away. But H2S turns up in this particular case at a paper mill in a confined space. Unfortunately, a number of workers actually did pass away in this particular instance, and that's locally here in Australia. But there's definitely other world areas. Equinor, for example, there's a young gentleman, unfortunately did pass away as well. He was, what's called it, in the wrong place at the wrong time, as they say, and yeah, was overcome by H2S. Excuse me. It does also appear in any sort of wastewater space as well. So there's various water and wastewater and believe it or not, in the biogas sort of style of space as well. So things like digesters, for example, from refineries and the likes. Everybody's very well aware of SRUs and the likes. So self-recovery units, for those that don't know it. Tank farms can and does happen if you've got crude management, things like that going on. So yeah, again, it really depends on your business area, and you do have to be mindful of using the word. Sometimes the decay, so I'm a little bit tongue-tied, the decay of products can produce and emit also H2S. So what is H2S? I've got a little bit of a piece here on I use the word a toxic summary on it, and again, quite insidious, quite a very nasty, probably one of the biggest issues in this particular gas. The most unfortunate part is, in very low levels, what it tends to do is actually deaden your senses and smells. Not unusual for other gases like chlorine and things like that as well. So what will actually happen is you become, loosely speaking, immune. Your senses will not pick it up from a sense of smell. So you don't believe that risk is there any longer. And what will tend to happen as you go through the increased levels of concentration through that space, if you're moving into that hazardous area, airspace, it can be absolutely horrific. And obviously you do have to be very careful from a first responder aspect as well. These are how some of these deaths do also escalate, unfortunately. May have a man down, that person coming to that gentleman's or person's aid, male or female, will then unfortunately also move into that airspace that is toxic, and unfortunately, depending on the level, it'll actually flood your lungs. You'll end up with a lot of liquid on your lungs, as it says there, respiratory and nervous system, and greater levels again end up with, unfortunately, death. So just from a H2S aspect, it is different depending on the LEL levels, for example, as well. So LEL in its own right, generally speaking, can be a lighter gas, not always the case as well. H2S is a heavier gas, typically lives in the low-lying areas, and very common to what we call confined space sort of processes. I think everybody's fairly familiar with the smell. It smells like rotten eggs for those that are unfamiliar with it. And as I said, I mentioned before, very small levels can actually deaden the sense of smell, which is quite sad, but not uncommon. Flammable. So some of these learnings from myself, actually I wasn't greatly aware that it was flammable, but depending on the range and the rest of the environment, you get the right environment level. Yeah, absolutely explosive. And some of what we call the exposure limits. So there is remits with regards to the exposure limits that your personnel are allowed to be involved with on a day-to-day basis. It may be the bottom piece, for example, a high level for short periods of time, what we call a short-term exposure limit, the STEL, so less than 15 ppm for 15 minutes or less. Over what we call an 8-hour time-weighted average, TWA, typically has to be less than 10 ppm. I believe that some of those numbers are currently being globally re-evaluated as well. So based on risk analysis and the industry in general, I expect those to be coming down over time. So that gives you a little bit of a quick snapshot, unfortunately, on, as I said, the risk of toxic gas and H2S in particular. Just moving forward in some of these key areas, as we're talking about some of the challenges in some of these H2S and applications for an installation aspect. In a lot of these applications, they are fairly well isolated within plant and process, which can be quite costly to physically do the rollout. Maintaining, again, to walk or move into that airspace, to actually do some maintenance on, dare I say, the reason why you're doing maintenance on, let's say, a H2S sensor in the field is either for calibration or there's a potential fault within it. So again, there's an element of risk as you move into that space. Obviously from a maintenance and a job spec, you'll be having your personal protection, your LEL, and obviously your local H2S point gas detector on yourself. But that unfortunately also only, dare I say, you have to be in that airspace when that sensor does go off. Sometimes, and again depends on, if you like to call it, the methodology of the business space, gas detection can be unfortunately viewed solely as a cost. So some of these aspects can have to be considered, obviously, moving forward for physically putting a unit out in the field. But they also can be barriers sometimes, and that is the justification, I suppose, of that capital rollout. My eyes, hey, at the risk of, dare I say, personal injury and dare I say, death, they should be negated and passed away. But in this particular instance, going forward, what we can do is actually eliminate quite effectively some of these risks in that sort of detection rollout. We've covered some of these points in that previous slide. I suppose it does talk about many of these high-risk sites do and can do completely unprotected. It can be boundary areas, for example, and again to use that point, poor access points that may be a thoroughfare, fixed, permanent, or semi-permanent. Again, as we spoke about, the portable users, obviously, it's mandatory when you're out in the field, depending on your site and obviously the HAZOP for that particular job and your job role and the scope of work you'd be intending on taking on. And that last point, I think, again, really does pretty much cover it as a soft comment. What we do, I suppose, in summary, in this particular case is with the 928 platform, as we look at this, the actual 928 platform in its own right is a wireless network. It's through its design, it is actually to extend and assist really in, again, use the word permanent or semi-permanent installations out in the field, and really to assist your plant and personnel. By design, we'll talk about it a little bit further down, it's by design in rollout, obviously it's ease in time, and obviously from a functionality of capital works of cabling, etc., is very easy to roll out. And what I do like about it, I suppose, as a platform going forward as well, you can actually now put them out in the field at a place that is applicable, as opposed to maybe not as functional as what you may have really required it to be physically in that point in space, in place and time. And obviously integrates into our the already existing and or potentially new Emerson, what we call wireless HART networks, which we touch on today, but we won't go into a lot of depth. We can definitely cover off, if you like, at a later date and time that works for yourselves. Please feel free to reach out to us and we can talk in more detail on a one-on-one. Introducing, or just moving into what we call the 928 wireless platform. As I'll click through this fairly quickly. I think, again, that slide is fairly self-explanatory. The actual 928 platform, by design, it'll be a multifunctional platform, and it's been designed for that by function. This little black piece you can see down the very bottom there, unfortunately I don't have a unit with me today. I was going to actually take it apart in front of everybody. That's actually now gone out into the field, and we're showing some clients with it today, in particular with a couple of guys out in the field, and they were very keen to have a bit of a look at it. But that little black piece you can see down the very bottom there, that's a modular click-on H2S sensor. As you work up through the top works, that's the interfacing piece, which is that aluminium piece. And then as you look at the top works, very familiar to what we call the Rosemount HART family of transmitters that you may be familiar with, anything from pressure, temp, level, etc. And then works obviously off our the wireless HART protocol from a communications aspect. As you look at the front display, what I do like about it, it is very functional and clearly tangible. You can physically see what your measurement is. It could be H2S in this particular case, LEL or otherwise. It'll show you the ppm value and a real live reading at that moment in time. One of the other key areas that we do have, there is an option, and what you can do in this particular case is have what we call a TTL, or an alarmed output. I can't use the word relay because it consumes power. So we reduce power, we have what we call a TTL output, and this will then give you the option or the capability to now have this device mounted in a hazardous area, obviously from a detection point of view, have remote either indication or audio, so you can have anything from a hailer, for example, right through to a beacon alarming prior to you moving into that hazardous airspace. So yeah, from a functionality and design point of view, I'm really impressed with that forethought that the guys had when they engineered and designed this system. Obviously, we spoke about the wireless antenna and the likes. The antenna in the general function and portfolio space that we have in the Rosemount space, that antenna can be locally mounted or remotely mounted. Bearing in mind when we spoke of H2S being a low-lying gas, this can be mounted in a dark and gloomy space of your plant, and that antenna then can be remotely mounted to access the wireless HART network. And then prior to moving into that airspace, if you had to do some testing over and above, obviously point gas detectors and the likes, prior to ending your work permit entry and the likes, you can have, obviously, as we spoke of, audio or even visual indications of that airspace. And again, depending on your functionality and how often you want update times, you have one configurable up to 60 seconds. Just a little bit of a brief overview of some of the other areas. For those that are familiar with the Rosemount portfolio in the wireless space, obviously the power modules are hot swappable, which I do like that out in the field, so you don't need a hot work permit to physically change out the power module within the unit. 3-year battery life, and again that depends obviously on your update, and we're stating 3 years on an 8-second update rate. Which I use the word pretty modest. I think it works well. One of the key points is is a 6 to 8 H2S module in this space as we go forward. So it's a smart series. It's an electrochemical cell. We'll touch on electrochemical cells and how they work at a very basic level a little bit further down the slide deck. But what I do love about it, it's a smart unit, and we'll talk about that also a little bit further down from a calibration aspect. And again, depending on the environment that it lives in, we're nominating approximately 2-year service life with regards to it being an electrochemical cell. If it lives in a really H2S rich environment, one of the challenges in that space is obviously the richer the H2S, you do deplete the cell off faster. But what we do love about it too, with the embedded smarts within the cell, it does have a lot of diagnostics within its own right. Specifications are there for you to see, and absolutely reach out to us. We're more than happy to send that information through as we go. Probably one of the key points on this particular slide is obviously the environmental aspects of it, but really proud to say that obviously we've got IECX Zone 0, and we now have the radio frequency spectral approvals for Australia and New Zealand only just happened within the last month. So it was in October. So yeah, this is, as I say, it's a ready to go product now and to be integrated into your existing wireless network. So we'll talk a little bit about the components of an electrochem sensor. Obviously, for an electrochem sensor in this particular application for H2S, when you actually looked at that sensor, and you can actually unclip the bottom of it, which is this hydrophobic membrane technology, and loosely speaking, think of it like a bit of a Gore-Tex membrane. So obviously the gas passes through, but the liquid remains out, and it assists obviously in the longevity of that electrochemical sensor. You've got your sensing electrodes, you have an electrolyte which it lives in, and as I suggested before, the more often you apply H2S to it. So ideally living in these spaces, they're not always living in a H2S space. It's for personal safety, for people moving into that air gap space, and yeah, you'll end up with a longer lasting cell if it's not physically sitting in a H2S space consistently. We spoke about the electrodes, for example, the counter electrode, and we'll look at how this works in a general application of a gas pass-through, and obviously a reference electrode. So not dissimilar to a normal everyday electrochem, could be anything from a pH electrode or otherwise as well. If you look at your reference electrode, your measurement electrode, for example, and in this particular case we've also got a counter electrode. So heaven forbid you do have a H2S release, it'll go down and actually reach that point detector. That point detector will have the gas that will permeate through the membrane technology. What you will have is an oxidizing scenario where you'll end up with what's called electron flow between the two measurement electrodes. Oops, I've just gone one a little bit too far. And then based on that, what we do is actually amplify that, if you like to call that very small electron flow. and depending obviously the ppm levels that pass through, the gases consumed as it passes through and into the sensing element. So for that alarm to maintain, you do have to have obviously continuous gas to that space. So mounting obviously of these particular devices is very key to their success and functionality. If you mount it in an area where you're never going to see the gas, well obviously it won't alarm. I suppose the other part of it you'd have to be mindful of its air gap and spacing from a wind point of view, and it could be maybe in a thoroughfare area as well for transients going through from a workshop facility to the field, crib rooms, things like that. So again, the functionality for its design and placement in the field can be very variable now in this particular case. Just to touch base a little bit on the 628 sensor that we spoke of before. In obviously a workshop safe area, so it's you're not emitting H2S in an enclosed environment. You have to be very mindful and careful of that. From a workshop facility aspect, you're working with H2S gas. It's a known to no-go zone, and obviously, as we spoke of before, very small parts per million can actually make you either very sick, ill, or dare I say it, if you're in a very much confined space, at worst, it'd be very tragic. Talking about the 628 sensor, as it says, it's a smart sensor technology. What I do love about this and the whole functionality of the heart and the wireless heart scenarios, before you even go out in the field, you can now talk to that field device. In this particular case, the 928 platform, get a health update on how that 628 module is actually operating out in the field. Does it have any health flags and the likes? And then from there, you can actually predetermine, pre-calibrate one of these in your workshop environment. Bump test it, calibrate it, it holds that calibration data set, take it out into the field, obviously with your personal safety detection system and suitable workflow and job set. So for example, go out into the field, change out that module, plug it in, and basically it uploads and you're off and racing. So I suppose the goal in life as we go through some of the aspects is if we can limit your time in the field and work smarter, as they say, talking to the field devices through the wireless network. One of the other key little elements is it's actually a low volume cell. From a calibration point of view, you don't need calibration cups, so you don't need large volumes of, dare I say, quite a nasty gas. So some of these sort of elements have been really well thought out in the design and moving forward in this sort of style of technology. A little bit of a quick overview. I've pretty much covered most of it. So obviously diagnostics are there, they're on board. Plug in the new module, actually tell you, hey, I'm H2S, hey, I'm this, hey, I'm that. Obviously you can learn about different failure modes. Totally configurable, hot swappable on both spaces. You don't need work orders and hot work permits to change out sensor modules or power modules. High performance, obviously I won't get into the detail of the spec here and now, but I think it speaks volume for itself. It's definitely what I call when we've checked against wired systems and the likes. Yeah, we're very proud of that specification, and the T rating from a response level is definitely second to none. Certifications we spoke of, Zone 0, ICX, shipboard approvals if required. And as I suggested, we've got multiple outputs, obviously from a heart point of view, local displays, which I think is fabulous as well. And I think one of the key elements for me, which I think is really thought through the other side, you've now got digital outs for alarming. This is really just a quick overview of where it fits in our safety portfolio that we've got. I'm only talking about the field devices. I haven't talked about anything upstream of that, obviously from an SIS system, etc., alarming or otherwise. So through the suite of portfolio, obviously, main goal in everybody's life is if we can actually do containment of any hazardous gas or otherwise, LEL, etc. We can have through high pressure leak detection, we have what we call an acoustic gas leak monitor, which is that fellow there on the left. Moving off to the right, what you can have now is we have through our Spectrex portfolio, we have line of sight. We also do point LEL in a wide format. From a SIS aspect, obviously, in the wide aspect. And then moving further down, we then have our toxic portfolio range. We also do that in a line of sight. We do that in a wide point gas. And we also do that now in the first release on that 928 platform that we spoke of during the course of this session, which is the 928 with the 628 H2S. And then if it's in an LEL space, through our 975 portfolio, which we'll do at a later date, we have what we call a flame detection suite. So that can mix and match depending on the style of flame or the LEL we're looking for in a combustible aspect. We have flame detection for things like, for example, hydrogen, through to obviously standard methane sort of applications and the like. So yeah, we have a full portfolio suite in that area for those who weren't aware. Emerson prides itself on what we call best practice, or moving and working with key clients in what we call a top quartile business practice. And one of the key areas for us is actually, believe it or not, safety. As you can see there in that top left, which I think it really highlights one of our areas of concern, and there is that continuous improvement with our clients and our products going forward out into the real world through design and integration and the likes. Reliability obviously is key, emissions, and we can't forget while we're in business, basically for production. So some of these key areas when we do and sit down with, basically for production. So some of these key areas when we do and sit down with clients from a consultative point of view, which we do have consultative arms, we actually do sit down and we do planning and come out with what we call business activities that will assist clients in the best for business practice for what we call top quartile performers. And where I'm heading with this, which we'll look at next, which is a little bit of an exciting, I suppose, teaser with regard to our safety vision going forward. So top left there, to ensure safety, it's part of our operational certainty space, and the digital ecosystem is a platform that we have that complements that area. So from a digital transformation aspect, and I'm quite passionate, actually I think a lot of the data sets that are isolated in the field from a heart point of view is quite sad. For me, running workshops and the likes over the years, what I've always loved is if you can actually have a predetermined outcome or have an idea of what you're moving into when you're going into a hazardous space, you look into a field device. Quite often the case can be, it'll be a process issue, may not be through fault of the instrument, but you'll have a request through the operators in the work permit space to say, check out tag number XYZ. You'll go ahead to side, go through the process and go, guys, there's actually nothing wrong with it. There's something wrong with, more to the point, the application, or it's a process issue and they don't like the data sets that are maybe being presented to them. Alternatively, through the digital ecosystem, what we can do now is actually physically talk to the devices and obviously run applications when you have a number of items reporting around an asset. So one of the key elements of that, as I just click through the rest of it, I think it's fairly self-explanatory, is if you can get a window to the world without physically being out in the world, we're talking basic scenarios of reducing standard elements like slips, trips and falls, and also exposure to that hazardous space moving forward. So it's just a little bit of a quick comment and value proposition of what we're actually doing in that particular space when we're sitting down with clients and being in a consultative area for what we call, as I say, it's a digital transformation for safety. Moving into that area, in this particular slide set, everybody's probably familiar with our history in the plant web scenario, which is what we call our digital ecosystem, and it can go through from a very top level right through to a very basic level at the instrument point. What I'm just showing you here is a little bit of a teaser, and we will cover this in later sessions over the next 12 months. Very excited to say this has just been released, but we have now what we call real-time location systems, and that actually, believe it or not, works off our wireless heart network system. So then from there, as I click through to the next slide, hopefully that explains a little bit further. So what you have is, based off the success and the function of the wireless heart mesh network, what we can have now is these location transponders, to use that terminology, on you personally as an individual. You can now actually then be located in time and space on that particular plant. It could be based on your permit that you signed on for, and we'll touch some other topics and points. They then are located back through to what we call anchors, which you can see that bottom right hand unit, again working off the wireless mesh network. and then that'll then come back through to what we call gateways or potentially access points for interfacing, and then running into what we call a location system, which is in this particular case our an application you can have now. As I scroll through into what we call a location methodology for management of staff and personnel, and again, depending on where you are in that particular place and space. I won't dwell on this in a big way because it looks like we're running out of time. We might want to have a little bit of Q&A on the end. If there is some queries you do want to type through, please feel free to pop them through, and I'm happy to discuss them, or alternatively reach out to myself or staff in that particular space. I suppose a little bit on the left is the days have passed. Today, excited to say, in a wireless heart mesh network, we can now move forward, just from a technology aspect compared to some of the harder rollouts of technology. The infrastructure now is actually a lot easier in the anchor space, for example. So they're actually just, believe it or not, think of it like just a wireless access point as opposed to the wireless transmitters of old, or alternatively beacons and things like that, for example. Obviously, they're rechargeable, and over and above that, from an installation point of view, where when you're putting out anchor points and the likes, very easily rolled out with no wiring, basically. So one of the key concepts is basically geofencing, as we spoke of. So why is Bob in a particular workspace when he's signed on work methodologies only for a different part of plant? So geofencing can be part of it. Safety mustering is obviously another one, and man-down alerts. Something I haven't made comment to is that little RTLS, real-time transponder, so to speak, location sensor system. Believe it or not, actually has an emergency button on it, so you can physically have that tag and push that tag point, which will limit your point where you are physically on that plant. Safety mustering, obviously, I think it really speaks for itself, so you can account for personnel in that particular area of plant. Geofencing, I suppose, one of the other areas, let's say in conjunction with something like the 92S, if you have an alarm or alert out in the field, it's now a hazardous area, and your work permit has you signed on for that particular part of plant, or that person's still not quite in that plant zone, but they're actually scheduled to be there in the next 10-15 minutes, and there's been a H2S release. You can now be proactive to actually manage that individual away from that airspace. And for example, say we've got a southwesterly wind, you now have to move to that northerly space of northeasterly, so to speak, away from that potential risk of a H2S release. So that's me in a bit of a summary and overview. I think I've made it for time fairly well. Please feel free to pop through a couple of chat questions if you do have any. And over and above that, please feel free to reach out to myself or any of our Rosemount team in the Emerson world.